Hi, my name is Tom Sandry. I'm Technical Director here at ProTech Equipment Resources, and today I'd like to introduce you to battery maintenance and test equipment. We'll be focusing on load bank testing of a battery system. The units that we have in our inventory for rental is made up of the Megger TORKEL instrument. This is the model TORKEL860. The unit is a load bank set for DC discharging of stationary standby batteries. It is capable of connecting onto battery systems from 12 volts up to and including 480 volts. Through a single TORKEL unit, it will allow up to 110 amps of current to discharge through. If you do require to go higher in amperage, simply we would parallel additional load bank units and be able to step up in 110 amp increments. Some of the accessories that come with the instrument, we have obviously the power cord, your test leads, which will get connected onto the terminals of the battery bank that we're going to be discharging. And the TORKEL itself will actually regulate and control the rate of current discharge. You are capable of doing what they call constant current discharge through the TORKEL. It will monitor the entire voltage of the entire battery string. Now, if you are following IEEE recommendations for load testing, you know that you also, during the load test, need to be able to monitor the individual voltages at each individual cell or each individual jar. Now, for that, we offer the Megger, what they call BVMs, battery voltage monitors. These, in essence, are really just little voltmeters that will connect onto the negative terminal of each of the jars or cells in the battery bank, and these will actually monitor the individual voltages at each of the battery jars. Now, both the TORKEL and the battery voltage monitors will feed into the laptop computer, and the software program called PowerDB, Power Database, will actually act as our user interface for programming the TORKEL, and will also act as our final test report for when the load test is complete. The report will come complete with an overall chart showing the entire string voltage as it decays during the load test, and then as the ampere hours increase during the test. You will also have individual charts showing each of the jars or each of the cells and their voltages from start of test to close of test. Okay, hookups of the hardware is pretty straightforward and easy. Again, we are dealing with DC systems, so we do have polarity sensitive. Red would refer to your positive terminals, black would refer to your negative terminals. So, okay, you can see I put on some personal protection equipment. Now, whenever you're handling or working around batteries, you do want to be wearing rubber gloves, even on sealed cells, because if you do have any seepage or post-leakage, it will be corrosive, it will carry acid. If you are going to be working around flooded cells, particularly if you're going to be doing hydrometer measurements, also highly recommended that you are also wearing a rubber apron. Eye protection, again, even in a sealed cell environment, if there are damages or if there are internal problems to these jars during the load test, it could go ahead and cause a thermal runaway situation. Batteries are a dangerous item to work around. So, personal protection equipment, protect your hands and everything from any type of acids. Do not wear any kind of conductive jewelry. Do not use any type of metallic tools because, again, you have voltages at these terminals. Okay. Now, to connect the battery voltage monitors, we'll simply go ahead and connect onto the negative terminals of each of the jars. On the last jar, we will connect onto the positive terminal as well as the negative terminal. So, connection of the battery voltage monitors, very straightforward, very simple. We simply connect onto the negative terminals of each cell and or jar in the series that we're going to test. On the last jar and or cell, we have one BVM connected to the negative terminal, one BVM connected to the positive terminal.
Yes.
Now, to power up the BVMs, we have the little control module here. This will get connected into your computer.
Okay. Okay, let me give you my phone number. It's 972.
And all the BVMs will connect together utilizing standard
5550.
Ethernet or RJ45 patch cords. Okay, we've got all of our connections made. Let me just step you through what we did here. We connected the test leads to the TORKEL load bank unit. The positive or red lead going to the positive terminal of our battery string, and the black or negative lead going to the negative terminal of our battery string. We've also went ahead and connected our communication cable and fed it into our laptop computer so that we can both program the TORKEL as well as capture all the voltage and current and timestamp during the load test and capture it into our PowerDB test form. Now, the battery voltage monitors, what we had done here is we connected the master module where we provide DC input power to it, which then energizes each of the battery voltage monitors that are connected onto each of our jars. We connect using our first patch cord. We connect to the very first battery voltage monitor, which is connected to the negative terminal of the first and or, if you look at it as last jar in the string. And then from the output of that battery voltage monitor into the input of the next battery voltage monitor, output to the input to the input, and then finally output to the input of our final and last battery voltage monitor. So again, connection is fairly simple, fairly quick. Negative terminal of each of the jars or cells, except for the final cell where we will have the addition of the positive post connection. Okay? Now, we're ready to go ahead and turn the TORKEL on. And I would highly recommend that if you are renting the TORKEL, the very first thing that you do when you receive it is just hit your stop key and your escape key, just in case that there was a previous test that was being run and might have been interrupted or stopped. This will just clear out anything in the TORKEL, bring you back to the main menu where it says test battery. Again, just hit your escape key to bring you back to that point. Test battery, we will say OK or enter. Now, it's going to ask you to set current. You can program the TORKEL right from the front panel keys, but we're going to do that through the PowerDB software, and we're going to automate the system. So where it says to set current, feel free to just go ahead and hit your enter key and advance, because we will change that value via the computer. Next it will say switch on the F1 or your main circuit breaker. Okay, so we're just going to set our F1 switch or main breaker switch, and we're going to hit enter. And the Torkel will now sit at the monitoring screen. It shows that I have 51 volts on my 48 volt battery bank, but I have not actually implemented or begun to run the test. For that, I'm going to now go to the PowerDB software and show you how to set up your test form. Okay, now that all of our connections are made, we're ready to go to the computer. And when you first power up PowerDB, you'll notice that you come to the opening screen that says select an instrument. PowerDB is capable of supporting a wide variety of different Megger products. Today we're going to be using the battery and the TORKEL product. So we just click on TORKEL. The software will then go ahead and ask us to check our communication ports. If we're not sure what those communication ports are or what physical port the TORKEL is connected to, we have a convenient link here where we can go into the device manager, come over here to ports. Now the prolific USB to serial adapter, which is connected to my TORKEL, is actually on COM port number 4. My USB to serial, where my battery voltage monitors are connected, are on port 14, or COM port 14. So going back to our screen, we select port 4 for the TORKEL, hit OK. We would then select port 14 for the battery voltage monitors, hit OK. Now it also asks if I'm using a hydrometer. Now for today we're testing sealed cell batteries. There would be no way to take a hydrometer reading. As long as we do not have a conflicting serial port assigned, we can just ignore this and hit OK. And finally it'll ask us to go ahead and select which test form we want to use. We're going to use the automated battery discharge form, so simply double click to open up the form. And here there is an area where you can go ahead and customize your report by dropping in your company logo. The header information is not mandatory, but you may wish to fill this out with the name of the company or substation where you're doing the test. I'll just put ProTech equipment. I can put in temperatures, humidities. If I knew the batteries that I'm testing, their catalog number, model series, I can enter that information. Here where it says number of cells, if you recall from my setup, I have a 48 volt battery bank. Technically each of my jars has 6 internal cells, but I do not have access to those cells. So for my purposes, I'm going to treat the jar as a cell, in which case I would have a total count of 4 jars. The type of test I'm going to run is going to be a constant current discharge test in accordance to the IEEE standard 450. By checking this box over here, I can enter in test current and end voltage levels. So again, I'm going to run a constant current test, although I could run constant resistance, constant power. I can program in a custom current profile or power profile if I was doing, for instance, a UPS bank. I'm going to leave it as constant current. I'm going to discharge at a rate of 50 amps. And I'm going to bring each of the jars down to a cutoff voltage of 10.5 volts. And notice that Torkel will automatically take the 10.5, multiply it by the 4 jars that I told the Torkel that I'm testing, and my end battery voltage will then be set to 42 volts. I also can go ahead and put in warning and stop limits. For instance, I may put in a warning limit and say, well, when the battery bank gets down to 11 volts per jar, I want to be notified. When the battery bank gets down to 10.5 volts per jar, I want the test to end. Now, as we move down the worksheet, we see the controls for the Torkel and the BVM. Now, for the BVM, I'm testing, instead of a 2-volt jar, I'm actually treating each jar, which is technically 12 volts, as an individual cell. So I'm going to tell the Torkel that I'm on the 0 to 20 volt range. On both, I want to go ahead and show my test data on my form. And by checking the box over here, I can start and stop the Torkel through one set of controls. Now, the first thing I'm going to do is I'm going to come up to this little icon that says Initialize Instrument. It's the red box with the yellow lightning bolt. I'm going to initialize the equipment and actually communicate out, make sure that my communication ports are set properly. It's going to prompt me and say, did you remember to hit the F1 switch on the Torkel? We had done that earlier, so I will say OK. And at this point, I'm going to go ahead and start the test. It's going to prompt me that this will clear any data that is currently stored in the Torkel. That's all right. Running a new test is going to delete all existing records in the Torkel. OK. And now the Torkel has been activated. We are now discharging at a rate of 50 amps. If we actually look at the screen of the Torkel, we can actually see the voltage at the total battery bank. We can see that the Torkel has been now reconfigured and programmed for a 50 amp discharge. Ampere hours are currently at 0.4 ampere hours and our timestamp. To monitor it on the computer, I can come down here to page number 2, and as we can see on page number 2, I can show my battery bank chart where my top line here is actually showing me the voltage on the battery bank, the total voltage, and this will be a descending line as the battery discharges. Here's my warning limit, and down here we have my cutoff limit. Now also notice that we have the blue line, which is ascending, and this will correspond to my total ampere hours. If I want to look at the raw data that is being captured, I can come down here to my individual table, and it will show me the individual voltage values that are being sampled and captured. If I come over here to page number 4, here's where I'm monitoring the battery voltage monitors, and I can see the initial voltage in the darkened area here. This is the initial voltage that was captured and read at each of the individual jars or cells, and then the green bar is the current voltage level that is currently being read at the jars. So what I will see here is the green, as it goes ahead and comes down and hits the warning, Torkel will then hit indicate a warning to us. As the green bar comes down to the cutoff line, the battery or the Torkel will then end test when all cells and jars have reached the cutoff value. The value of monitoring each individual cell allows me to see if one of the cells in the battery string is possibly defective and is decaying at a much quicker rate than the remaining cells. If all of a sudden, for instance, cell number 2 was rapidly decaying, this gives me the opportunity to go back, pause my test, take corrective action, for instance, jumper out cell number 2, and then continue my test. I do not want that cell to decay or go to cutoff premature, because there is a risk that that cell may go into reversal. And that concludes our very simple training course on how to configure and use the battery voltage monitors and battery load bank Torkel test set by Megger. Thank you for your attention.